Hi, folks. So my name is Strickx. Thanks for the introduction. Couldn't probably have said it better myself. So I'm going to talk a bit about documentation and why documentation matters. Like I wrote down in the blurb, documentation, whether we want it or not, is an important part of our life. It's one of those things that it's either it's always there or it's not, and usually when it's not, it's usually the worst. So I'm going to talk a bit about an issue that we've seen. This is probably now 3 years ago. Time is weird. This is 2020, right? But specifically, we had an issue with one of our top-of-rack switches in our location in Newark. So that's EWR03. So next time, if you're communicating with Cloudflare at any point in time and you see a reference to net-whatever, that's our internal ticket number, so now you know. So we were seeing weird things with our switches, specifically a single switch. We were seeing egress port errors. So normally, the way that our network is architected, we do ECMP internally, which means that a set of compute nodes within a data center will be advertising the same prefixes. And then you get basic 5-tuple hashing, and that just lands up on a specific metal. So what we were seeing was egress port errors on a specific port for a specific metal. And normally what our standard operating procedures for that is we basically just disable the node, right? It's cattle, not pets, so we just disable the node, and that should kind of deal with it. We file an RMA, we get our remote hands to clean the fiber run and swap the optics if needed. But the weird thing was the problem didn't go away, right? What you can see here, the different colors are actually different egress ports, are actually different nodes. So what we were seeing was whenever we were actually disabling the node, the faulty traffic or the bad traffic was, instead of just going away, because port errors, right? It actually just moved to a different node. Fortunately, on the same switch, that made it a bit easier to do this visualization. And the annoying thing with this is it's not super straightforward what was happening. So what one of our engineers actually thought was happening is we run Cisco Nexus switches in our data centers, and they do cut-through switching, which is kind of nice, right? Like you get super low latency. It's always kind of fun, but there's a bunch of shortcuts that those switches take, and one of the things is CRC verification. So what it was doing is the Nexus was, or our expectation is that the Nexus received a broken frame, and instead of just dropping it, it was actually just clobbering the CRC to make sure that it got rendered as incorrect, and then forwards it out so that the receiving side actually just drops the frame on receipt. But the weird thing with that is, obviously, Cloudflare doesn't run a just flat network where there's just leaves, right? Like we have equipment in between. So then the weird thing is, if the Nexus switch was receiving broken frames, why was nothing else upstream, like our core routers or edge routers? Why was none of that seeing those issues? So then you might think maybe it's an issue between the core switch and the leaf node. That wasn't the case either, because again, we weren't seeing ingress errors. So what we did, trying to figure out okay, what are these errors? What is this actual problem that we're trying to debug? One of our SOEs enabled a specific option on the NIC to basically still receive and keep broken frames, which is RxFCS, apparently. We did TCP dump. And this is the TCP dump. I hope you've all seen a TCP dump. This should be nothing too special. The important things here are, let's see, oh, laser, cool, is that it's ER span traffic, and we'll talk about that in a second. So it's ER span traffic. So for those that don't know what ER span is, it's a Cisco, as far as I know, Cisco thing that allows you to do port mirroring, but instead of doing it directly to an actual physical port, it gets encapsulated into GRE, and that GRE traffic gets sent to a specific destination. So the thing with that was we looked at the frames. If we look at the TCP dump, you'll see that everything here is green. So what that means is actually the packets are fine, because Wireshark has this really nice feature where it color codes all the packets and the nice things. This should have been red. If this thing was actually anything broken in there, the frames should look red. So why wasn't this red? Well, fortunately, I have friends in weird places, and one of those places is Cisco TAC. And someone was really kind of me to basically tell me that the nexuses have this really annoying tendency of looking deeper into packets than they really should. Specifically, what the nexus in this case was doing, instead of just looking at the encapsulated GRE traffic, it was looking at what's in the GRE packet and complaining about what's in the GRE packet. So we weren't receiving broken frames on the nexus was just looking too far into the packet. So obviously that's not documented anywhere, because why would it, right? Like that would make it easy. Like I'd have like nothing to talk about, and that'd be a shame. So what does this have to do with documentation, besides if there's anyone from Cisco here, please update your Nexus documentation and tell us that you're looking into GRE packets, that'd be nice. Well, let's have a look back at like that TCP dump. This might look familiar to people. There's this DNS service that's been running on it for a while. So where did this come from? Well, this is Cisco documentation. I know it says from 2014, but it's still online. I checked. That's not supposed to be there. Like that's Cisco documentation, and they're very kind of providing it, which is nice. But they're setting the destination IP address to 1.1.1, and I think they're also setting the source IP address to 1.1.1 somewhere on another page. So that doesn't help, because we're network engineers, and sometimes we're lazy, and what we'll do is just copy-paste whatever it is that the documentation tells us to, and then whenever we notice, oh, that shouldn't be there, we'll update. So what we were seeing is that instead of receiving, like UDP traffic on port 53 or TCP traffic on port 53 or a bunch of the other like fancier protocols that we have these days on 1.1.1, we were receiving GRE traffic, and that's usually not supposed to be there. And like, it's not like this is a new service, right? Like it's been around since 2018. So we've been doing this for the last 4 years. And, so update your documentation. But obviously, I wouldn't be here if we weren't making our own mistakes, because we're not flawless either. We made this tweet in 2020, and that's slightly awkward, but mea culpa and all that. I spent probably like 6 months before I started doing this slide deck, making sure that all of our internal documentation was cleaned out, as well as the external documentation. Otherwise, it'd be a very awkward conversation. But that's not the only thing, right? So it's perfectly fine to make mistakes or to use prefixes that are technically not supposed to be used for whatever. But then when someone calls you on it, the basic expectation is, oh, right, I messed up, sorry about that, won't happen again. Not this. That's just a tad awkward. It's not the greatest thing. It's like, we call you on it, and because, like these, they're not supposed to be there, right? So own up to it, deal with it, learn from it, become a better engineer, right? Because that's how we become better engineers, is learning, and learning through mistakes is probably the most awkward and most painful way of learning, but it's also usually the way that sticks with us. So just don't do this. Because, there's two RFCs, and people spent quite a lot of time and effort into writing these RFCs, and they're specifically for documentation purposes, right? So there is IPv6 blocks and IPv4 blocks specifically reserved for documentation. Like, take that in mind. Like, an IPv4 block these days, like a /24, goes for around, what, $15,000? There's 3 of them. That's a lot of money that we're like actually reserving for documentation, so it'd be a waste if you don't use them. So for those in the back, just a reminder that RFC like 3849 and RFC 5737, they're a thing. Please use them. It will save me a lot of time and effort, because I don't want to keep doing this. For IPv6, it's a very straightforward one. It's 2001 DB8 /32. So it gives you, plenty of room for activities. You can split it into /48s. You can split it in /64s. You can do whatever the hell you want with it. It's not going to be routed. There's nothing you can do badly with it. And if people copy paste it, that's fine, because they're a bogon, so they're going to be filtered, right? Because everyone implements manners, right? The same thing for IPv4. Like I said, there's 3 prefixes. So like you can even set up a fancy lab and start routing /24s. they're there, right? Just use them, please. One of the comments I got from this talk at RIPE is that actually I should update this slide deck and add another RFC because there's also an RFC for documentation AS numbers. Same principle, like stop using AS1, AS2. I know AS1 is owned by level 3 and is not actually being used at this point, but like AS2 and AS3 are. Don't, you know, like it's bad enough that people use it for prepending, which is also quite funny. So in summary, because this is basically just it, right? Like stop using 1.1.1.1 for documentation and use the bloody prefixes, that'd be appreciated. But yeah. I know it's hard, and you know, it's like it takes a while to kind of get better at things, but please. But that's it from my side. I know this was a quick one, but I don't want to keep people from lunch because hungry network engineers are bad network engineers. So in that case, I want to thank you all for your attention, and I want to thank you all for going through your documentation right now and updating everything that mentions 1.1.1, and that'd be very much appreciated. Thank you.